So maybe 2 cents about myself. My name is Marco. I'm one of the co-founders of Revolve Space. I'm Italian. I'm an aerospace engineer by education. I studied at Polimi in Milan. Then I moved to the Netherlands in Delft, where I studied space engineering for the master. Now it's a couple of years that I've moved to the dark side of business, but that University of Technology still have a very dear role to me because that's where I met the other co-founders and we started Revolve Space. So just some quick facts about our company. We are relatively young, so we were founded 2 years ago. We are based in the Netherlands, in Norway, incubated at the ISASBIC, close to Estec. We also have a subsidiary in Italy, in Turin, and we're very happy to be part of those two ecosystems, which are great for the developments going on in space. The team is made by 7 amazing engineers. And now I would like to, in this presentation, tell you a little bit more about what kind of problem we set up to solve and our initial product. So we started the company because we saw a problem that is very dear to us, and to introduce it, I just want to make the distinction for how we kind of think about satellites ourselves. So of course, there are two main parts. The payload, which actually is the very important aspect of the satellite. So it's the one that is making money for the company to test the satellite. So the one that generates the data, then the company, the operator, goes to sell. And then there is the satellite bus, which is basically what we have to do because space is very hard. So the payload cannot survive by itself. You have to make a bus around the payload so that the payload can survive and make the data. What we have seen in recent years is that while there are more and more new technologies coming up for payloads, so the improvements in performance are almost on a yearly basis. We can think about hyperspectral images, for example, as a recent trend. We don't really see the same for satellite buses in the category of CubeSat, the one that we started up to focus on. And the consequence of this fact is that payloads, which is again the part that really is making the money, operates for only a fraction of the time that the satellite spends in space. So we're building satellite costs millions between manufacturing and operations, but then the useful time of the satellite there in orbit is only maximum 20%. There are a few factors, of course, that goes into this downtime, and we set out to figure out which one is the biggest, the most meaningful to solve first. And power, so the limitation in power, are the main factor here. So that's why we have developed SARA, which we call it the Space Sunflower. SARA is a system that connects to the solar panel of the satellites and rotates them autonomously to track the sun. So always having the solar panels facing the sun gives you double the energy on average. And with this energy, then the satellite operator can decide what to do, but we envision the usage for increasing the duty cycle so that then there are more data available. SARA has a really unique characteristic in the sense that we had to cope with our biggest competitor, which is the status quo. So the fact that people don't like space mechanism so much. So we had to come up with solutions to kind of making it easier for people to adopt the solution. And we have engineered for us reliability since the beginning. So SARA with a backup mechanism doesn't cause the loss of the mission in case the system is to fail, but we bring back the panel to a default configuration so that the system is able to still generate power, and the mission and the operator can still continue to generate data. The system is fully autonomous, and this is because it's made out of those sub-assemblies. So we have the mechanical part on the top of the electronics, but we also have the sound sensors. So we all have the chain from sensing to actuations, and those are on the images that you can see on this slide. We also decided to include those in our system. So we want to make it very easy for people to adapt to solar panels of third parties. Here in these slides, there are a few use cases for which we have received a very good feedback for so why the system is useful. We generally think about application in space in two main categories. So there is the telecommunication, and then there is Earth observation. What we have seen and experienced is that telecommunication is an application where it's easier for our system to enter because the benefits are much more clear and are immediate. So applications such as IoT or RF monitoring. While for Earth observation, we feel this has to mature a little bit more, but there are stuff on the satellites that can make this process of adaptation much faster. So now there is more and more onboard data processing for Earth observation to have real-time insights instead of the raw images. And those kind of processors consume a lot of power. Trends like hyperspectral images also require cooling for your sensor, and is an extremely power-hungry part of the satellite. And mobility is just becoming a mandatory part on the satellites now, but it will become even more as the year goes by. And one of the main enabler for the adaptation of electric thruster it's reducing the power consumption. So with a system that can give you more energy, we feel like we can be enabling more mobility on the satellites. Now I wanted to just give you quick glances about the first product that we built. Those are going to be a bit faster slides because they are not so exciting, but to give you a sense for the size of the system, it's very small. It occupies 1/5 of a U. So of course it stays on the stack of the PCB 104. In thickness is 23 millimeter. It weighs 1/3 of a kilos, and we have made it very easy, as much as plug and play that is possible for the space industry, to adapt it on the top or on the bottom of the satellite. But the design is flexible enough that we can accommodate in the middle for those type of customers that have different type of solar panel configurations. We receive a normal, from the side of electronics, we operate on 5 volts. The power consumption is at maximum 6 watts, but on average 3. From the testing that we've done, we already see that those requirements that we set are going to be much higher than what we are going to see actually in operations. And on the side of communication, we're quite flexible, so we have both RS as canal as the interfaces for. From the side of performance, so for us is mainly pointing. We have a Ronostan sensor indeed, so we have an accuracy of less than 5 degrees for pointing, for sensing, sorry, and then instead the actuation can go below 1 degrees. We rotate plus minus 180 degrees, so we don't do 360 continuously. Where we are right now, we are at year 5. Here you can see one of our older engineering models. So now we have redesigned it based on feedback from the first users. We are going through the testing campaign in the next months. So this is an exciting time for us. And then we have the IOD scheduled for next year. This of Sarah is just the first piece for our company. We have a much more ambitious vision. So we want to be the supplier that is able to guarantee a continuous data generation and transmission for satellites. And we think that the first step to do is to rethink some of the components that goes into the satellite bus, because we think that although CubeSats are improving, they can be much more powerful, flexible, and capable. So we don't want to make the bus ourselves, at least as the first step, but as a space supplier, we want to position ourselves with these 3 main values in mind. So everything that we are doing, we are trying to stick with those main drivers. And since we are in the market of space mechanism, availability is indeed the key factor. Also, we have a really commercial focus. So we want to see us LEO that is more and more industrialized. So with more and more space operator coming online. So not only on paper, but really deploying those hundreds and thousands of satellites. And in order to get there, we feel like that there needs to be a established space supplier able to support this development of the infrastructure. Also, something that we want to bring that is we feel like it's going to be helping those companies, those operators. It's a faster and more responsive customer support side of things. So going very fast through those points. For reliability, our design is fault tolerant. We are also going through an extensive and representative testing campaign. We are doing already pre-testing now to the risk reaching TRL 7 late in the next months. Something that was really important for us to get to this point fast was to partner with a small manufacturing plant so that we can have the mechanical parts to iterate really fast. From the point of view of the industrialization, so making the system able to scale to large volume, we took the first steps by designing for manufacturing and for assembly. So optimizing already not for very particular mission in this space with very high requirements, but with the requirements of LEO constellations. We are also using automotive components mainly for the electronics, so those are available in tens of thousands, the one that we're using. Later, we are planning to bring up the manufacturing line, so that also is going to help us really fulfill those orders. From the customer care point of view, we see this actually firsthand with our own supplier. So sometimes it happens that responsiveness is not really as it should be. Also, price transparency sometimes is not there really. The process of getting quotes and exchanging documentation is very complicated sometimes, and we want to be one of the company leading this kind of transition to to a market where it's very easy to exchange NDA, to have access to documentation. Everything is very fast, so that we want to have the company don't lose time waiting for suppliers when they are building their satellites. Thank you for your attention. We are Evolve and we are giving satellite superpowers.
Perfect. Thank you, Marco, for the update again on the progress and what generally the Revolve Space stands for, what your values are, and what are you currently developing. So I think that's really important. Again, technology, as we're saying, right? You said your main competitor is the status quo, right? That it's really been. People were really not open towards, again, this gimbal that you're developing, right, for the Sarah with the small sats, right? Even though the similar technology has been existing for the bigger satellites, right? Is that correct before, Marco?
Yeah, indeed. This piece of technology, of course, exists since a while in very, very expensive satellites that are in GEO. We see more and more now also for smaller satellites. I think now is kind of the correct timing where people are bringing this technology for smaller satellites, because 10 years ago we were considering CubeSat or smaller satellites more as a playground or a toy for university to actually learn about space engineering. But now companies are really making money out of those small satellites, so requirements for performance are really increasing, and we feel that the natural next step for enabling those type of application is to kind of borrow the great piece of technology that are there for very expensive satellites to the smaller form factors.
Perfect. And last year that we had a discussion, Marco, you also mentioned that Sarah enables basically the companies and the mission the mission owners, it enables them to increase their mission output, right? So the productive mission outputs by 20%, I think that was the number, if I'm not mistaken. So
yeah,
can
that
you elaborate on that a bit more and explain it to the audience just a bit more, how that works?
Yeah, for sure. Like as I mentioned at the beginning, really, like our mission that we want to carry on is to make satellites, is to let people extract more value from the satellite. And for us, value really coincide with the duty cycle. So we feel like the duty cycle is really not that there as it could be. And having an higher duty cycle can allow you to really make a more a better mission, like a more powerful mission. So by having more power, which is the first limitation, bringing down this duty cycle, we feel we can make the first step. Of course, there are other limitations after, so that can be also a plan for the future for us to move from one limitation to the other. But the one that we feel now is very, very important is the fact that power is halting down the duty cycle.
Perfect. And especially now with the new regulations and this 5-year deorbiting limitations that have been put in place. So it becomes even more and more important, obviously, the power and to maximize the time of the mission that you have towards the productive time, right? And not just, being there in orbit and recharging, right? So that's very important. So next question of mine to you, Marco, obviously, as being a a young startup, right? So in Europe, what are some of the challenges that a company like yours would be facing in this emerging space economy, and how you and your team are overcoming those challenges?
That's an interesting question. So of course, being an early stage company, there are many challenges that you have to face. Well, for us, clearly one of the biggest milestones is reaching Tier 9. So going to space. That of course is very important. We're making the first steps, and I think that the ecosystem in Europe is quite supportive. Like there are plenty of space companies that are are there. So I think it's about being really proactive and going after those possibilities. Other challenges, of course, are linked, but they are similar to every other companies, I would say. So access to talented people, and also financing. So I think those are not only for us earlier stage, let's say.
Mhm. Especially now with the recession and all of the things going on worldwide. So yeah, funding is one of the biggest issues. Okay, perfect. So the next question to you, Marco, is we have still some time, and so audience, I would like to also remind the audience that they can drop more questions to you as well there, Marco. But my next question for you will be, so what kind of testings and validations have been done? You touched upon it just a bit, but that's ensured for you that the gimbal will be able to withstand this space harsh environment for a long period of time.
Indeed, this is a very important part, and it's going both like on the business case and on the technology. So business wise, trying to really validate the fact that this is something needed in the market. So this we are doing by working closely with the first users, exchanging basically the requirements, making sure that the design is compatible with their satellites, getting their help in drafting also what kind of testing data they want to see. So this is something that we are doing on the side of customer. On the side of technology, we are doing basically all the tests that are required to qualify a components, and even more than that. So for us, one that is very important. So aside the common one like TVAC, vibration, and that kind of things, is to ensure the lifetime of the system. The way that we're going about this is we are building in-house a small TVAC chamber, and then we are letting the system run for a very long time. So with the data out of these, we are confident that we can justify the lifetime that the satellite operators want to see. Because one of the other driver, of course, aside reliability, is also a useful lifetime. So CubeSat generally they don't stay there for much time, and also this requirement is going higher or longer. So we are targeting a lifetime of 5 years.
Perfect, wonderful. All right, so my next question will be a bit moving away from the gimbal and the hardware side of it. As a company, I know that you've been lately recruiting, and you were also offering a lot of internships. So as yesterday we had a very interesting panel about the workforce development, right? And we discussed some of the issues with the current workforce, retaining the workforce, and some of the skills that are missing in the current workforce. So how do you feel, Marco, and how do you see it as a founder of a company in the new space industry? What role does internships play in bridging this skill gap that, let's say, individuals have from fresh out of academia and university towards where they can fully take on the jobs and skills that are needed in the space industry to succeed?
Yeah, first, actually, this is my chance to thank you again for with the work with Altair Careers, because of course it has been very helpful for us. Indeed, we had the various interns in the meanwhile. Also, we have recruited for a full-time position. On the side of the internship, I think they play actually a very important role, because they allow you to basically work with people that then they can stay in the company at the end. So it's kind of a trial period, and being close to Delft, and also with the links to Italy, we have access to some great university. So I think the internship part is very important. It helps to select then the right people with the right attitude, of course, to stay in a young and dynamic company later at the end of the internships.
Perfect. And there was another question yesterday which I posed, which received some mixed responses, obviously, which was regarding the college degrees and basically the background educational, right? So what we were discussing, and majority of the panelists yesterday agreed that the industry players will have to become more flexible in that regard, right? So obviously the point was that if you're hiring, let's say, an engineer or a hardware, it's not too much room for flexibility there, right? But when we're talking about the, let's say, position that requires more of a skill rather than, you know, the degree, right? So in the management side, in the, let's say, other less maybe technical side of things. So how open do you believe the company should be in that regard? And another point is when the companies, how do space companies also attract individuals from adjacent and different industries to move into the space industry? So what would be your point on that?
That's very interesting, I think. And for us, something that we are trying to do is to be quite flexible. So, of course, the perfect background might be skills wise on space engineering, because well, that is kind of the closest there. But we feel like different point of view are definitely beneficial. So, for example, we have been recruiting for this software position. By the way, embedded software engineers is a difficult skill, so let's say to get on the team. And we feel like it doesn't necessarily to be something from the space industry. So we feel that if we have the right attitude and you have good software engineering skills, then even if you don't come from application in space, then you can learn really fast. It's more about the attitude, I think, and the fit with the people.
Perfect. Yeah, I agree with that. And another point was yesterday also what they mentioned, that space industry still being a relatively niched and a smaller industry if you compare that to other industries like tech industry and other similar industries like that, which space industry maybe right now doesn't offer too much of those financial incentives. So there's much higher salaries maybe in some other industries that are adjacent. And space industry relies more on a passion side, right? So inspiring people to move into the space industry. So do you agree with that standpoint, or what would be also your point on that? I would love to learn.
No, I definitely agree. Particularly then depends on the company, because if you're joining early stage startups, then you know by default that you're not gonna get the higher salary you can get if you go to work for a very, very big and established company. So if you're joining one of those company, you're doing it because of well, the affinity with the people, you enjoy the experience, you believe in the mission. Something that of course typically companies of our size use is to give part of the ownership of the company also to the key people that are joining. So at the end you feel like you're part you're part of the company, and then success and failure, you're really like completely part of the company, let's say. So you're not doing it for immediate financial returns, but I think you're playing the long game here.